Welcome back to Blackthornprod. I'm Noah. Now, for quite a while, I've been wanting to make some more tutorial series on my channel, where I take you step by step through the creation process of an entire game. And so to start off, I'll be showing you how to make a very simple yet fun little endless runner using, of course, Unity and C#. By the end of this series, which should last no more than 3 videos, you'll have a similar creation up and running, which you can of course expand on as much as you like. We'll learn how to create a simple player controller, obstacles, spawning, and also get our game gradually increasing in difficulty. We'll also see how to make a cool repeating background, how to display health and score with UI, and finally add some juice to our game with some particle effects, screen shake, and sounds. Now, this small tutorial series is aimed for beginners, but that doesn't stop intermediate or even advanced level developers joining in on the fun and trying to make their own unique endless runner. Note that you can download the entire complete project over at GitHub. The link will be in the description. Okay, just before starting, here's a big thanks to Pebble and Wisp for their awesome support on Patreon. With that said, let's get cracking. Okay, first things first, let's take a look at my Unity project, which currently has this ghost-like player character with this floating animation, as well as a spiky obstacle sprite I drew in Photoshop. Now again, you can download these assets via GitHub, or you can create your own unique assets, which I highly recommend. Just grab Photoshop or some other free 2D application like GIMP or Inkscape and have fun making a player character and an obstacle. Once that's done, we can create the player controller, which, as you've probably noticed, is very straightforward. The character simply hops up or down depending on what arrow key the player presses. Note that the character isn't moving forward, it's the obstacles that actually move towards him. That, as well as the moving background, give the impression that the character is charging forward. Okay, so I'll create a new C# script called player, drag and drop it onto my little ghost, and open it up. In my update function, I'll check whether the player has hit the up arrow using a simple if statement. If he has, I want to move him up of a certain amount on the Y axis. To do so, I'll make a vector2 variable called target pose up here and set that equal to a new vector2 in my if statement. Again, we don't want to change the character's X position. We simply want to increase his Y position, so I'll type transform.position.y plus 5 because I would like my character moving up of 5 on the Y axis. Of course, this value may be very different for you, and you might very well want to tweak it. So it's a good idea to make a public float variable called y_increment and replace that hard-coded value with this float variable instead, which we can set in the inspector. Awesome. If, however, the player hits the down arrow key, then I want the player obviously going down, and so I'll replace that plus with a minus. All this code, however, will not move our character. We need to set the character's transform position to be equal to this target pose variable. So just type transform.position is equal to target pose here and here. And now my ghost will have X and Y coordinates exactly like my target pose. In Unity, I can now set a value for my Y increment. 5 is good for me, and then I'll hit play. And you'll see that my character can move up and down brilliantly. Now, you may not want this extremely snappy movement, but would rather the character transition smoothly from one position to the other. Doing so is also very easy. Instead of setting the player's transform.position equal to the target pose, simply get the character moving towards that position using the famous and awesome vector2.moveTowards function. So you're moving the player towards target pose at a certain speed. So make sure to make a public float variable called speed, plug that in there, and multiply it with time.deltaTime. Quick reminder, time.deltaTime is used just to make sure that the player will move at the same speed on all kinds of computers. In other words, a very powerful, fast PC won't get our character moving faster than a slow and buggy one. And that will do the trick. You can now set a value for speed in the inspector. I'll go for something pretty high, like 100, and hit play. And you'll see that my ghost no longer snaps from one position to the other, but smoothly transitions between them. However, you've probably noticed that the player can for now continuously move up and down and even go off screen. let's fix that. Back in Visual Studio, I need to not only check whether the player has pressed the up or down arrow, but also whether he's reached the limit of how high or low he can move to. So I'll make two new float variables, one called max height, the other min height. I'll then check in that if statement if the character's Y position is smaller than the max height. If it is, cool, the player can move up a notch. If not, this statement will return false and the player will not move up. Same for this statement, except we'll make sure that the player's Y position is greater than the minimum height he can reach before allowing him to go down a notch. In Unity, I'll set max height to be equal to 5 and min height to be equal to -5 because I don't want my player moving higher than 5 and going any lower than -5. And that's it. Our player controller is working perfectly. And that will mark the end of this first video in this Endless Runner tutorial series. I hope you were able to easily follow along and enjoy the process. In the next video, which should come out in 2 or 3 days, we'll get to work on the obstacles, spawning them in game and making them deal damage to the player. Now note that I have plenty tutorial series I am very hungry to create. From a top-down 2D bullet hell game to a roguelike platformer like Spelunky, this Endless Runner is a fun little warm-up series. I hope you're as excited as I am. With that said, don't forget to hit the like and subscribe buttons, which is just so appreciated and helpful. You can also support me financially via Patreon, like these top supporters, which would be absolutely wonderful. Okay, stay tuned, have a great day, cheers!